In this video, we're going to look at three word problems using our exponential growth and decay formula. So here, remember, A is always our starting amount. We take 1 plus or minus R, which is our rate, as a decimal, and we're raising that to X, which normally is the number of years of the situation. Now, we obviously need to understand why we're having this plus and minus. The plus means when we're growing, we're going to add the rate, and when we're decaying, we're going to minus the rate. All right, let's look at a few examples here. So looking at example one, it says Facebook has 1.3 billion active users in 2017. The number Y of active users increases by 14% each year. It wants us to write an equation that represents the number of users T years after 2017. Okay. So to start this problem, I want to know how many users am I starting with? Well, it tells me 1.3 billion. Now, I could just put 1.3. I don't need to put the billion down. I'll just need to know at the end of the problem that my number's in billions of users. Then I'm going to multiply that by 1 plus whatever my rate is. And the reason why I'm using a plus sign here is because it's saying it's increasing by 14%. Now, I need the percentage, the rate, as a decimal. To get that, I simply just divide by 100, which would give me 0.14. So I'm going to add 0.14, 14% increase. Then I'm going to close the parentheses, and I just need to know how many years have passed. Okay, so I'm going to put a T there for the years. This would be the equation. I'm starting with 1.3 billion. I'm timesing by 1 plus 0.14 for T years. Part B then says how many people will be actively using Facebook in 2021. Well, I just need to ask myself how many years have passed since 2017 and 2021, and the answer to that is 4 years. So I just plug in a 4 for my equation. So I'm going to get y equals 1.3 times 1 plus 0.14 to the fourth power. On my calculator, I can type this in just as it's written. So on my calculator, I'm going to type in 1.3 parentheses 1 plus 0.14, and then I'm going to raise that to the fourth power for 4 years. Hit enter, okay, and it says I have 2.19, so I'm going to round that up to 2.2. And then I just need to remember that because the 1.3 was in billion, this is technically in billions. Okay, so it's 2.2 billion. Okay, moving on to a second example here. In 2013, it says, lions were introduced into a national park. This is the equation that models it. Okay, so they're giving us the equation, and that represents the number of lions in the national park after 2013. They want to know, what does the 24 represent in this situation? Well, remember, this first number is always our starting value. Okay, so that's our start. So it's really saying the population, I'm going to write POP for short, population of lions started at 24. Then it asks us, what does the 1.25 represent in the equation? Well, the 1.25 tells us how much the population is growing. So in this case, it's greater than 1, so we know that the population is growing. And then we need to say at what percentage the population is growing at. To get the percentage, remember we just minus 1 from this number, which would give us 0.25. And then if we times by 100 to switch it back into a percentage, we would get 25%. So what does the 1.25 in the equation represent? Well, it tells us the population is growing at 25%. Part C then says, how many lions will there be in 2018? To answer the question of how many lions will there be in 2018, we look to see that our model started in 2013, so we know 5 years have gone by. So we just need to simply plug in a 5 for the x value in our model. So we would get y equals 24 times 1.25, and we're raising that to the fifth power. So on my calculator, I can type this in. I'm going to type 24 times 1.25 raised to the fifth power, and I get 73 lions.